Welcome back. We're going to do one more graph and one more of these word problems here too. So let's get to it. All right, so we're going to graph this equation here. Again, we have the function in standard form. So we're going to use the vertex calculation where we do x equals negative b over 2a to find the x coordinate for the vertex. What's our b and what's our a? Pause the video and answer that question. Okay, hopefully you pause the video. The b here is 5. A is 1/2, so it's going to be negative 5 over 2 times 1/2, which yields negative 5 when you do the math there. Okay? Now, that's the x coordinate for the vertex, right? We have to find the matching y coordinate, which we will do by plugging that negative 5 into our equation here. So f of negative 5 is going to be 1/2 times negative 5 squared plus 5 times negative 5 plus 6. So negative 5 squared is 25. Half of 25 is 12.5. Negative 5 times 5 is going to be negative 25, so minus 25 plus 6. So let's see here. 12.5 minus 25 is negative 12.5, plus 6 is negative 6.5. Okay. Make some room here for some calculations. So then we'll make a XY chart. Okay, put that vertex in the center. Pick 2 points before negative 5, so less than negative 5 would be like negative 6 and negative 7. More than negative 5 would be like negative 4 and negative 3. Okay, and then we'll plug these in. Okay, I'm just going to use a calculator here to do this to speed up the calculations for us, because otherwise, I don't want to waste time with stuff that we don't necessarily need to spend time on. Okay, just plug those numbers in. Okay, so negative 4.5 is what I get here, negative 6, and negative 4.5. So we'll plot these points. Okay, again, I'm going to use this as my y-axis, this is my x-axis. I think that should be sufficient for what our purposes are here. And again, I'm just going to count by ones as well. So negative 5, 1, 2, 3, 4, 5, and then negative 6.5. So 1, 2, 3, 4, 5, 6.5 would be right there. Okay, and then negative 6 would be right there, and negative 4, negative 6 would be right there. And then negative 3, negative 1, 2, 3, 4.5 would be right there, and then right there. Okay, you can draw in your axis of symmetry if you want to, just kind of help. I didn't do it in the last graph, but it's not a bad idea to help you kind of get your wits about you. Let's do another point like the y-intercept. We can just plug 0 in for the x's there. Those are all going to be 0, so it'll just be 6. So 1, 2, 3, 4, 5, 6. There's our y-intercept. We can use symmetry. It's 1, 2, 3, 4, 5 units away. So 1, 2, 3, 4, 5 units away would be right there. I think that's enough points then to go ahead and connect the dots and kind of get our graph. So I'll just do something like this. Okay. Voila. Okay. So let's continue on here then, right? Let's also maybe well, it's kind of hard to tell what these x-intercepts are here, so perhaps we should go ahead and set this equal to 0 and solve. So let's see here. 0 equals 1/2 x squared plus 5x plus 6. So I'm going to multiply both sides by 2 to kind of deal with this 1/2 coefficient here. So I'll get 0 equals, again, so I'll multiply this side by 2, multiply this side by 2. So we get x squared plus 10x plus 12, and I'll see if I can factor this here. Can we come up with two numbers that multiply to 12 but add to make 10? The answer is no. Okay, so we'd have to use a quadratic formula there to get the zeros because it does not factor. So you have to do x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so that's going to be negative 5 plus or minus the square root of 5 squared minus 4 times 0.5 times 6, so 13 over 1. So in other words, negative 5 plus or minus root 13. Okay, which then would be negative 5 plus root 13 is one of the zeros, and negative 5 minus root 13 is another 0, which is approximately negative 1.4, we'll say, and negative 8.6, we'll say here. Okay, so those are our zeros approximately. Okay, domain here will still be negative infinity to infinity, right? Because we're just going to go left and right for forever. The range here, what's the range going to be? What's the lowest y value you see here? Okay, it's the vertex, right? What's the lowest vertex point? Negative 6.5. Okay, so we're going to go from negative 6.5 to infinity. Okay, y-intercept we already have graphed. It's just the 0.06. Okay, increasing. Well, it's increasing on this interval right here, so that's from negative 5 to infinity. We are decreasing where? Right here. Okay, don't let this arrow trick you here. Okay, we're not going up, it's decreasing from left to right, so it's coming down on this section. Okay, so it's decreasing from negative infinity to negative 5. And then we also want to talk about end behavior. As x approaches infinity, f of x, not f of x, we have our function here is, oh yes, f of x. As we go far to the right, we're going up. So that goes to infinity as well. And as x's go really far to the left, as they approach negative infinity, f of x is also going up. So, negative infinity.